Right, so A is a 0.23 and B is a 0.58, and the question goes on to say that BC can be expressed as column vector 4, 0. Now they ask you specifically for part A to represent AB as a column vector. So let's do part A here. Alright, represent AB as a column vector. So AB, okay, is equals to OB minus OA. Alright, AB. Now OB can be gotten from here. Alright, now OB can be represented as 5, 8. Alright, and OA can be gotten from here. Okay, it's in coordinate form. All you have to do is put the x component, this is the x component. Okay. Right, and this is the y component. Okay, all you have to do is put the x component on top. So 2 and 3. And there you have it. You have your answer. 5 minus 2 is 3. 8 minus 3 is 5. Okay, 8 minus 3 is 5. So there you go. A, B. Okay, as a column vector can be represented as 3, 5. Okay, this is your question A. Let's do B, alright? B. Okay, find the coordinates of point C. Alright, now you know that they gave you a clue, BC. They told you that BC is 4, 0 as a column vector, and you know that BC can be represented as OC minus OB. Alright, okay, goes up, my working goes up to here. Okay, since BC is equals to OC minus OB, OC is something we are trying to solve. OB is already been given to you, which is 5, 8, represented as a column vector. Now BC has also been given to you. Can I replace BC? Okay, let me replace BC with 4, 0. Okay, as we manipulate this, OC, okay, can be written as 4, 0 minus bracket 5, 8. 4 minus 5 is negative 1. Oh, okay, apologies, I have to add. Okay, I have to add. Because of my negative sign here, if I shift 5, 8 over, it becomes positive. Alright, 4 plus 5 is 9, 0 plus 8 is 8, and there you go, OC is 9, 8. Therefore, C is equals to 9, 8. Alright, so this is how simple it is. So that's your answer to B. Okay, next question. Okay, write C here. Find the coordinates of A, B, C, D. Find the coordinates of D, point D, if A, B, C, D is a parallelogram. Alright, so okay, we've got A, we've got B, we've got C. So let me just draw and show you how it roughly looks like. Okay, this is your y-axis. Okay, this is your x-axis. Now A is right about here. Okay, now B is right about here. Okay, A is 2, 3. Okay, and B is 5, 8. okay, right about here. And C has also been given to you. I mean, you've already calculated it in your previous question, okay, which is 9, 8. Okay, so C is 9, 8. So you know that a parallelogram will, it will look somewhat like this. Alright, okay, where AB is parallel to DC and BC is parallel to AD. Okay, so let's solve this question right now. Okay, so we know that we know what's AB, we know what's BC. We've got to find what point D is. Alright, so we say that D can be here. It's possible that D is here, isn't it? So we say that AB, okay, AB is here, is parallel to CD. Sorry, is AB is parallel to DC. So AB, it can be written that AB is equals to DC. Okay, they have got the exact same gradient. Okay, can we let the coordinate D be x, y? Okay, hence column vector D, OD, can be represented as x, y in this form. Okay, since AB is equals to DC, we've already found AB. AB equals to OC minus OD. Alright, DC, okay, and AB is actually equals to 3, 5. Represent it as a column vector. OC has been given 9, 8, and OD is just x, y. Isn't it? Okay, so 3, 5. Okay, a bit messy here. Okay, so 3, 5 is equals to 9 minus x, 8 minus y. So now we can solve. 3 equals to 9 minus x, x equals to 9 minus 3, which is 6. Okay, now 5 equals to 8 minus y, y is equals to 8 minus 5. All I'm doing is I'm shifting y to the left and 5 to the right. Okay, when you shift, your sign changes. When you shift to the opposite side of the equation, your sign will change from plus to minus, from minus to plus. Alright, so, oops, I've made a mistake here. Okay, okay, this is 8 minus 5. So y is equals to 3. Okay, so therefore the coordinates of D is actually equals to 6, 3. Now 6, 3 is right about here. Okay, can you see that this is a parallelogram? Right? Okay, can you see that? Okay, this is a rough sketch, okay, because I've got no markings. I'm just doing it so you can understand. Alright, so this is your answer to part C. Not too complicated. All you have to know is that AB, okay, A moves to B, has the same gradient as DC. Okay, you sort of have to visualize how it looks like in order to solve it. Alright, so it'll be good to help you, if you actually draw like a little picture and draw a graph and you know where the points approximately are. Okay, and then you surmise that D could possibly be here. So if you want to find the coordinates D, AB, okay, is equals to DC. Okay, therefore D is equals to 6, 3. Alright, so there you go. This example is a question on position vectors and column vectors itself.